The year was 1973. Gas prices were exploding. Insurance companies were punishing anyone who bought a muscle car. New emissions laws were choking the life out of America's biggest V8s. Almost overnight, the horsepower war was over. To a lot of people, it looked like performance cars were dying. The golden era had ended. Dealerships sat filled with unsold muscle cars that nobody wanted anymore. The insurance premiums alone could bankrupt a young buyer. Gas stations had lines stretching for blocks. Some ran completely dry. America's love affair with horsepower seemed finished. But what almost nobody knows is that one unlikely engine refused to go quietly. Instead of getting bigger, it got smarter. Instead of adding more cubic inches, engineers bolted on something many Americans still didn't trust: a turbocharger. That decision didn't just save an engine family. It created one of the most feared street machines of the 1980s. Most people know the legend: the black paint, the sinister look, the embarrassing street races, but very few know how close Buick came to killing the entire V6 program before one spinning turbine changed everything. And what happened next rewrote American performance history. Back in the early 1960s, Buick wasn't even planning to become famous for V6 engines. The company had built its reputation on smooth, powerful V8s that whispered luxury. That's what customers expected. That's what salespeople promised. That's what the brand represented. But accountants saw something different. They saw a market shifting toward compact cars. In 1962, the company introduced a compact 90-degree V6 derived from its aluminum 215 cubic inch V8. The new engine displaced 198 cubic inches, or about 3.2 liters. It featured a bore of 3.75 inches and a 3.00-inch stroke. Compact, simple, and inexpensive, it produced around 135 horsepower. On paper, it made perfect sense. It saved manufacturing costs. It improved fuel economy. It fit perfectly into Buick's smaller models. The problem? Customers didn't want it. Americans still believed there was no replacement for displacement. V8s ruled the highways, and six-cylinder engines were considered economy motors. Anything less than 8 cylinders meant you couldn't afford the good stuff. Walk into a dealership, and salesmen steered you away from the V6. "You don't want that," they'd whisper. "Let me show you the V8. Sales disappointed management so badly that Buick sold the engine's manufacturing rights to Kaiser Jeep in 1967, just 5 years after introduction. Gone. Most companies would have walked away forever. Buick executives certainly thought they had, but the world changed. By the early 1970s, fuel economy suddenly mattered. The 1973 oil crisis hit like a freight train. Overnight, every manufacturer scrambled to build smaller, more efficient engines. Corporate average fuel economy regulations were coming. Government pressure intensified. Customers who once demanded V8 power now begged for anything that sipped fuel instead of guzzling it. That's when Buick realized they had made a huge mistake. The very engine they'd abandoned was exactly what the market suddenly demanded. Worse yet, their competitor was using it. Jeep had continued developing the V6, proving it was reliable and efficient. In 1974, General Motors bought the rights to the V6 back from Jeep. Engineers modernized the design and increased displacement to 231 cubic inches, or 3.8 liters. The bore remained at 3.80 inches, while the stroke stretched to 3.40 inches. Compression ratios varied between roughly 8.0, 1 and 8.5, 1, depending on emissions requirements. The engine wasn't glamorous. It made around 105 to 125 horsepower in naturally aspirated trim. It wore cast iron construction. It featured pushrod valve actuation. Nothing exotic, nothing exciting. It wasn't winning races. It wasn't exciting anyone. It was just another emissions-strangled engine doing its best to survive in a hostile regulatory environment. But there was a problem. Every competitor was chasing the same shrinking horsepower numbers. If Buick wanted attention again, they needed something completely different. Something nobody else was doing. Something that would separate them from the sea of mediocre performance. That's when someone suggested turbocharging. The idea sounded almost crazy. Turbochargers had appeared on aircraft during World War II and had shown up on cars like the Chevrolet Corvair Monza Spider and Oldsmobile Jetfire during the early 1960s. But those systems suffered from reliability problems, confusing maintenance, and primitive controls. Owners complained, mechanics refused to service them, dealerships dreaded warranty claims. The Oldsmobile Jetfire required a special turbo-rocket fluid mixture that confused customers and led to catastrophic failures when forgotten. The system became a maintenance nightmare. Many executives believed turbocharging was already a failed experiment. Why revisit something that had already embarrassed the company? Why risk another public relations disaster? The engineers disagreed. Instead of abandoning the concept, they believed technology had finally caught up. Material science had improved. Electronics were becoming more sophisticated. Understanding of thermodynamics and combustion had advanced considerably. Most importantly, they had something the 1960s engineers never possessed: desperation. Their biggest challenge wasn't making power, it was keeping the engine alive. A turbocharger forces more air into the cylinders using exhaust energy. More air means more fuel. More fuel means more combustion pressure. Suddenly, bearings, pistons, connecting rods, head gaskets, and cooling systems experience loads they were never originally designed to handle. Under heavy boost, cylinder pressure skyrocketed. Detonation became the enemy. One uncontrolled explosion inside the combustion chamber could melt piston crowns in seconds. Connecting rods could bend or shatter. Head gaskets could fail catastrophically, mixing coolant with oil. Everything had to be reconsidered. The engineers lowered compression to around 8.0. 1. Strengthened internal components, revised ignition timing, and carefully calibrated fuel delivery. They upgraded piston materials. They revised ring designs. They improved cooling passages. Still, the real nightmare was only beginning. Nobody had production-level experience with turbocharged V6 engines in this application. Every test revealed new problems. Every dyno session exposed weaknesses. Heat became a constant battle. Exhaust gas temperatures exceeded 1,600 degrees Fahrenheit under full boost. The turbocharger itself glowed cherry red. Engine bays became ovens. Underhood components melted. Hoses degraded. Wiring insulation failed. Engineers spent months redesigning heat shielding and improving airflow management. In 1978, Buick introduced one of America's first modern production turbocharged engines. It wasn't a V8. It wasn't a sports car engine. It was the humble 3.8-liter V6. Using a single Garrett turbocharger feeding a Rochester Quadrajet carburetor, the engine produced around 165 horsepower and approximately 275 pound-feet of torque. Those numbers don't sound shocking today, but context changes everything. Many larger V8s of the era struggled to produce similar horsepower after emissions equipment strangled them. A 1978 Corvette with the L48 350 cubic inch V8 made just 185 horsepower, only 20 more than a V6 two-thirds its size. Suddenly, a compact V6 was competing with engines nearly twice its size. The first turbo system wasn't perfect. Turbo lag was significant. Step on the throttle, nothing happened. Wait, keep waiting. Then suddenly the turbine reached speed, boost arrived, and torque hit like a hammer. Unprepared drivers often broke traction unexpectedly. Transmissions struggled with the sudden surge. Drivers either loved it or hated it. One magazine compared the experience to being rear-ended by a freight train. Another wrote, "It's like two completely different engines occupy the same space." Enthusiasts began calling it the light switch effect. But there was another issue. Carburetors and boost pressure didn't always cooperate. Keeping fuel mixtures correct under varying boost levels was incredibly difficult. Too lean and pistons melted. Too rich and power disappeared. The carburetor was designed for naturally aspirated operation. Boost pressure confused its metering circuits. Float bowls pressurized unexpectedly. Fuel delivery became erratic. Engineers spent countless hours redesigning fuel circuits and wastegate controls. They added special pressure-referenced fuel regulators. They modified carburetor venting. They recalibrated wastegate spring pressures dozens of times. Every improvement brought them one step closer. And then electronic fuel injection arrived. That changed everything. By the early 1980s, Buick engineers paired turbocharging with sequential electronic fuel injection and computer-controlled spark management. Now the engine could constantly adjust fuel delivery, sensors monitored boost pressure, oxygen sensors checked exhaust composition, NOx sensors listened for detonation. Ignition timing could be retarded the instant NOx sensors detected detonation. The computer made thousands of decisions per second. Instead of guessing, the engine was thinking. That was revolutionary for an American performance car. Detroit had traditionally relied on mechanical simplicity. Carburetors, distributors, and mechanical fuel pumps ruled. Electronics were viewed with suspicion, but Buick committed fully. Horsepower climbed steadily. The turbocharged 3.8-liter reached 180 horsepower, then 200, then even higher. Each calibration improvement unlocked more potential. Each software revision enhanced drivability. The engine that had once been considered disposable was rapidly becoming legendary. But Buick wasn't finished. Someone inside the company had an even crazier idea. What if they built the fastest American production car using a V6? Most people would have laughed. The Corvette still represented Chevrolet's performance flagship. Ford had its Mustang. Camaro dominated the pony car conversation. Performance meant V8 engines, rear-wheel drive, and rumbling exhaust notes. Who would take a Buick seriously? Buick built luxury cars for retirees and middle management. Performance wasn't their territory. The answer came in 1984, the Buick Grand National. Dark, aggressive, almost entirely black, no chrome, no bright trim, no apologies. Its appearance looked more like something from a crime movie than a luxury division. The blacked-out wheels, smoked taillights, and menacing stance announced intentions before the engine ever started. Under the hood sat the turbocharged 231 cubic inch V6. Horsepower initially stood around 200 with approximately 300 pound-feet of torque. It wasn't overwhelming on paper, but torque arrived with brutal force once boost built. Street racers started noticing something strange. Friday night stoplight confrontations weren't going as expected. Expensive V8 muscle cars were losing. European sports cars were struggling. And the quiet Buick sedan kept disappearing into the distance. Word spread quickly. Don't race the black Buicks. That V6 has something weird going on. I swear it's faster than my Corvette. Stories multiplied. Urban legends formed. Every city had tales of unsuspecting Camaro or Mustang drivers getting destroyed by what looked like a grandmother's car. But Buick engineers weren't satisfied. They knew there was still more hidden inside the engine. They'd been conservative initially. Reliability concerns, limited boost pressure, warranty fears, restricted tuning aggression. But real-world experience proved the engine could handle more, much more. The Garrett turbocharger grew more efficient. Intercooling entered the equation. By cooling compressed intake air before it entered the cylinders, the intercooler increased air density while reducing detonation risk. Cooler air meant more oxygen. More oxygen meant more power without raising boost dangerously. Simple physics. Huge results. The intercooler mounted horizontally above the engine, fed by a functional hood scoop that actually flowed air instead of serving as decoration. In 1986, the intercooled version arrived. Output jumped to 235 horsepower and 330 pound-feet of torque. Again, the numbers underestimated reality. Owners quickly discovered these engines made considerably more power than advertised. Independent testing often suggested closer to 250 horsepower. Some dyno runs showed even higher. Quarter-mile times dropped into the low 14-second range straight from the showroom. Some magazines recorded 0 to 60 miles per hour in about 5.7 seconds. That embarrassed cars costing far more. Ferrari owners looked nervous at stoplights. Porsche drivers stopped challenging black Buicks. Corvette owners made excuses. And then Buick built the ultimate version, the 1987 GNX. Only 547 examples were produced. Each one numbered, each one documented, each one destined to become a legend. ASC and McLaren partnered with Buick to transform the already quick Grand National into something almost mythical, a larger Garrett turbocharger, unique engine calibration, revised intercooling, improved suspension, functional fender vents, ceramic-coated exhaust components, low-restriction exhaust system, specific transmission calibration. Every detail mattered. Officially, Buick rated it at 276 horsepower and 360 pound-feet of torque. Many insiders believe the real figures exceeded 300 horsepower and nearly 400 pound-feet. Why underrate it? Politics. Nobody wanted Buick publicly outperforming the Corvette. GM's hierarchy demanded respect. Chevrolet held performance supremacy. Buick built comfortable cruisers, not supercar killers. The official numbers protected corporate relationships, while the actual performance spoke for itself. Road tests stunned the industry. 0 to 60 happened in around 4.7 to 5.0 seconds depending on conditions. Quarter-mile times reached approximately 13.5 seconds at over 102 miles per hour. For 1987, that was astonishing. The Ferrari Testarossa managed 0 to 60 in 5.2 seconds. The Porsche 911 Turbo hit similar numbers. Both cost triple the GNX price. One magazine famously called it the fastest production car in America. Think about that for a moment. Not a Corvette, not a Camaro, not a Mustang, a turbocharged Buick V6. But success didn't come without sacrifices. High boost placed enormous stress on head gaskets. The thin, multi-layer steel gaskets occasionally failed under extreme conditions. Modified cars frequently exceeded 20 pounds of boost, pushing cylinder pressures well beyond factory expectations. Fuel pumps became critical upgrades. The stock pump flowed adequately at factory boost levels, but modified engines quickly overwhelmed it. Weak injectors caused lean conditions. Lean conditions caused detonation. Detonation caused destroyed engines. Owners quickly learned one lesson: ignore detonation, and the engine would punish you. Experienced tuners became obsessed with knock counts, air-fuel ratios, and ignition timing. Scan tools became essential equipment. Wideband oxygen sensors replaced guesswork. Proper tuning separated reliable power from catastrophic failure. One experienced mechanic reportedly joked, "The turbo doesn't kill these engines. Bad tuning does." He wasn't wrong. Remarkably, the engine itself proved incredibly durable. Its deep skirt cast iron block handled boost levels few engineers had imagined during its original 1960s design. The even fire configuration reduced vibration and stress. The conservative factory compression ratio provided safety margin. The simple pushrod valvetrain eliminated timing chain and variable valve timing failures. Forged aftermarket crankshafts, stronger rods, improved pistons, and larger turbochargers eventually pushed modified versions well beyond 600 horsepower. Some race builds crossed the 1,000 horsepower mark. Drag racers discovered the platform's potential. Dedicated shops specialized exclusively in turbo Buicks. Communities formed around modifications and tuning, all from an engine family that had once been considered disposable. Isn't that incredible? The very engine Buick, nearly abandoned, became one of the strongest turbo platforms America ever produced, and its racing success only reinforced the legend. Turbo Buicks dominated NHRA stock classes, became legends in drag racing circles, and built devoted communities of tuners who constantly discovered new ways to extract more performance. They ran 9-second quarter miles, then 8-second. Some eventually reached the 7-second range. Street-driven examples regularly embarrassed purpose-built race cars. Even today, decades after production ended, pristine Grand Nationals and GNXs regularly sell for extraordinary prices. A genuine GNX often commands well over $150,000 at auction, while exceptional low-mile examples have crossed significantly higher depending on provenance and condition. Some have exceeded $200,000. Replicas exist, tribute cars exist, but collectors know the difference. VIN numbers tell the truth. Documentation separates authentic from fake. Nothing replaces the originals. Ironically, the very forces that created the Turbo Buick eventually ended its reign. Stricter emissions standards continued evolving. Front-wheel drive platforms became General Motors' priority. Corporate restructuring shifted performance investments elsewhere. The accountants who once demanded efficiency now demanded platform consolidation. By the late 1980s, production of the rear-wheel drive G-body platform came to an end. The legend was over. At least officially, its influence never disappeared. Modern turbocharged performance engines, from 4 cylinders to V6s and even V8s, owe part of their acceptance to pioneers like Buick's 3.8-liter turbo program. Manufacturers eventually realized forced induction could deliver both efficiency and incredible performance. Engineers who worked on those Buick programs moved throughout the industry, carrying knowledge and experience. The lessons learned informed future developments. The mistakes made prevented others from repeating them. Today, turbochargers are everywhere. Family sedans, pickup trucks, luxury cars, supercars, EcoBoost Fords, turbocharged BMWs, boosted Audis, even Ferrari adopted forced induction. What once seemed like risky engineering became the industry standard, and it all traces back to engineers who refused to let an overlooked engine die. Engineers who believed smart design could overcome displacement disadvantages. Engineers who persisted despite skepticism. That's what makes this story so remarkable. The Buick 3.8 wasn't supposed to become a legend. It was supposed to disappear into history. Instead, one turbocharger transformed an ordinary V6 into a machine that humbled V8s, shocked the automotive world, and proved that smart engineering could beat brute force. Sometimes the greatest innovations come from the most desperate circumstances. Sometimes the best solutions hide in plain sight. Sometimes refusing to quit makes all the difference. If you enjoyed this deep dive, let me know in the comments which forgotten engine or turbocharged legend you'd like to see next. And don't forget to subscribe, because some of the greatest stories in automotive history are still hiding where most people never think to look.